Enough. Well, ladies and gentlemen, dear colleagues, dear friends of the HD community, it's a pleasure to welcome you now to the next session, and that is short communications. My name is Kathrin Reetz. I'm a neurologist from Aachen, and I'm happy that my co-chair is here. He is Eric Reits, professor for cellular imaging from Amsterdam. The program is very promising with a quite variety. So we have hot topics from imaging, cognition, but also physiotherapy, and finally arts. So that's really good. We have 5 minutes for the talks. After this, we have 2 minutes left for questions. All over the place, there are microphones. So please, if you have questions, go to the microphone or we will come to you. Now I will hand over to Eric for the introduction for our first speaker.
Thanks a lot. Yeah, the kickoff will be given by Nicola Hobbs from the UCL, co-lead facilitator of the EHDN Imaging Working Group, but more importantly right here is also that she works on the HD young adult study on the characterizing of the earliest neurodegenerative diseases changes in HD. The stage is yours.
Thank you very much. So I'd like to thank the organisers for the opportunity to present my poster to you this morning. So I'm going to be talking about some of the earliest neurodegenerative changes in HD and insights from the HD young adult study, and we call this HD YAS. So to start off with, the main aims of HD YAS were to perform deep phenotyping in an HD cohort further from onset than had previously been studied. We wanted to try and establish when disease-related markers first become detectable in terms of cognitive and neuropsychiatric measures, biofluids, and also neuroimaging, which is what I'll focus on now. And ultimately, we want to identify potential endpoints for future prevention trials. So our cohorts. So at baseline, we recruited 64 individuals into our HD gene expanded group. They were on average 24 years from predicted motor onset, and they were all young adults. We also recruited 67 controls, and we've seen our participants twice so far with an interval of about 4.5 years between their visits. In terms of the HD ISS, at baseline, 81% were stage 0 and 17% was stage 1. Over that 4.5-year interval, about 20% progressed from stage 0 to stage 1, no one progressed from stage 1 to 2, and no one regressed. So we've performed quite a wide range of neuroimaging in YAS. We wanted to look at volume and atrophy, white matter microstructure, iron and myelin content, compensation, and structural connectivity. So we really wanted to get an idea of what the earliest changes in the HD brain were. Because I need to be quite swift now, I'm going to focus on longitudinal change in these two domains, but for everything else, please come and see my poster. So looking at microstructural imaging. So here we map the diffusion of water molecules through the brain in order to probe white matter integrity. So we've looked at a whole range of diffusion metrics over these 6 white matter regions of interest, which we think are implicated very early in the disease process. So our microstructural results. So several of our diffusion measures showed very subtle but significant loss of white matter integrity in our HD gene expanded group compared with controls over all 6 of our white matter regions of interest over the interval. So to illustrate this, as an example, we've plotted change in mean diffusivity against group for all 6 regions of interest, controls in grey, HD gene expanded group in pink. And you can see very subtle longitudinal changes even in this pre-manifest cohort so far from predicted onset. Additionally, change in several of the diffusion measures was significantly predicted by age and CAG. So moving on to our macrostructural imaging, we measured change in volume in these 6 predefined regions of interest. So we've got our local measures of putamen and caudate, known to be very vulnerable in early disease. we've got our more global measures: white matter, grey matter, whole brain, and lateral ventricular volume. So our imaging results, we found highly significant volume change in the HD gene expanded group in all of our regions of interest over the 4.5-year interval. And here we've plotted longitudinal change in volume against group for all 6 regions of interest. And I think the take-home message here is that the differences are particularly pronounced in the caudate and the putamen. Furthermore, longitudinal volume loss in the caudate, putamen and white matter was significantly predicted by age and CAG. So just to look at the striatal volumes in a little bit more detail, on the left-hand side we've got putamen volume against CAP 100, on the right-hand side we've got caudate volume against CAP 100. Orange denotes stage 0, green denotes stage 1, and the black lines show the longitudinal within subject change. And the take-home message from this graph is that we are detecting and measuring very subtle longitudinal neurodegeneration in all of our HD gene expanded participants, even those with the low CAG on the left-hand side of a low CAP 100 on the left-hand side of the graph, and those who are at stage 0 on the top sections of the graph. So in conclusion, we've seen elevated rates of brain atrophy, and very subtle microstructural white matter changes are already evident in HD ISS stage 0 and 1. And this is in the absence of any longitudinal cognitive or clinical change. So we think that caudate and putamen atrophy may offer robust markers of early pathology. They may show promise as potential biomarker surrogates of disease progression for future prevention trials, particularly in combination with other very promising measures such as CSF NFL and PENC and somatic expansion ratio. And I'd encourage you to go and look at the posters that I've outlined here for more information on that. So I'd like to finish by saying a big thank you to our wonderful HDYAS participants, also to our funders and collaborators. Thank you for listening.
Thanks so much, Nicola. There's time for one question, and we really encourage also the younger generations from the EHDN family to ask a question. So you get free drinks over lunch if you do. And a question, please. First time you can ask a question, you can make yourself immortal.
Not young. Sorry for that. Nicola, fantastic talk. Could you comment on your thoughts as to the landmarks that should be used going forward to define HD ISS stage 0, given your results?
So moving from stage 0 to stage 1.
Yeah.
So I think that the caudate and putamen are good options, but I think with everything we do in science, the signal you get is a combination of the underlying biology, but also the sensitivity of the techniques that you use to measure that underlying biology. So I think at the moment our volume measures are probably the most sensitive out of all of the imaging measures, but maybe the techniques that are used to measure them could be revisited. So for the HDISS, I think free surfer was used, and potentially there could be some slightly more sensitive techniques. But, that's just my opinion.
Thank you very much.
Thank you.
Now we come to our next speaker, Professor Nelly Gorgio-Karistianis. She is Pro-Vice Chancellor at the Monash University in Australia. Welcome. And her talk will be about brain age as a new measure of disease stratification in Huntington disease. Nelly, it's a pleasure.
Thank you very much. Thanks so much to the organisers, and it's wonderful to be here. I'd like to acknowledge my co-authors as well as my postdoctoral fellow who can't be here with us today, Pubu Abiyanse, who undertook the research that I'll be presenting today. So as we all know, accurately characterising Huntington's progression is essential for developing effective therapeutic interventions, yet we are challenged by its heterogeneity. So we set out in this particular project to explore brain-predicted age as a sensitive measure of disease progression, and we also wanted to leverage brain-predicted age for patient stratification. So what is brain-predicted age? Brain-predicted age was developed by James Cole at the Imperial College London, and it's a measure of how old your brain appears compared to your actual age. And it's calculated using T1 weighted scans as well as computational models and machine learning algorithms in order to look at the structure and size of different parts of the brain. So as an example here, we can see a healthy female who's aged 30 years of age. Her brain predicted age is around 30 years of age. If we have a look here, at an extreme case of multiple sclerosis, it's a female aged 48 years of age. Her brain predicted age is around 64 years of age. What's important here is we can calculate what's known as the brain pad score in years. And the brain pad score is the actual chronological age subtracted by the brain predicted age. So in the case of this female with multiple sclerosis, we can see that her brain pad score is around 15 years, showing an accelerated brain. So the study design here included data from PREDICT, TRACK and IMAGE-HD. We had a total of 953 participants, and we evaluated just under 4,000 scans from multiple visits. So our methods involved calculating brain predicted age using T1 weighted images. We then undertook 2 analysis pipelines, one looking at cross-sectional analysis, which involved correlating baseline chronological age and brain predicted brain age. We then used brain pad score at baseline to correlate with CAP score. And then for the longitudinal analyses, we compared brain pad and CAP scores to see which produced a better fit for disease progression. We then analysed longitudinal brain pad as an outcome measure for each CAP group. And finally, we used brain pad in longitudinal analyses to determine group clusters. So the results here are from the cross-sectional analyses. You can see here the relationship between chronological age and brain predicted age for each of the different CAP groups. Obviously for CAP group 1 being healthy controls, there was no correlation between chronological age and brain predicted age, but there was a significant correlation between chronological age and brain predicted age for each of CAPs 2, 3 and 4. In panel B, we correlated brain pad at baseline with CAP groups, and we see here that high brain pad was associated with higher disease severity as denoted by CAP group. So in terms of the longitudinal analysis, using brain pad, our longitudinal analysis produced 5 distinct group clusters, A to E, and we plot brain pad score with the 5 clusters at baseline, of which you can see here. We also looked at the correlation between cluster order at baseline, which produced a positive relationship with CAG repeat lengths, but there was no correlation between each of these clusters and CAP score. If we have a look over here at the panel B, the rate of change in brain pad we plot here with the rate of change in other biomarkers for each group cluster, other biomarkers being your traditional markers, cognitive markers, as well as volumetric markers, including the putamen and the caudate. Visual inspection shows that brain pad group clusters have variable patterns of progression for each of these different measures. And the rate of change in brain pad score, however, seems to be higher for brain clusters A, B and C, as well as D, compared with the rate of change in other markers. So finally, in terms of conclusions, we show here that longitudinal brain pad analysis produced 5 distinct group clusters, all of which demonstrated a positive relationship with CAG repeats. The rate of change in brain pad score was higher than for cognitive and brain volumetric biomarkers for most of the brain pad group clusters. And what we can take home in terms of implications is that these findings may provide new avenues, new information that may support improved stratification of HD progression, and brain pad could be used with other biomarkers to further improve selection of participants for clinical trials. And I'd like to acknowledge all the studies and all the PIs, as well as the funders and the participants for their participation in these amazing studies. Thank you.
Thank you, Nelly, for this great presentation of this really important topic, as we have learned also from other neurodegenerative diseases that brain age might be has a relevant impact. Are there any questions from the audience? We have time for one question.
Yeah, great data. Could you elaborate on the rate of age acceleration that you see? How many years compared to control, compared to normal?
How many years, pardon? Can you repeat the question?
How many, what is the level of aging acceleration that you see? I mean, how many years are we talking about? I wasn't clear about this from your presentation.
Sure. That varies depending on the different stage that the individual is in, but it's generally roughly between 5 and 20 years.
Okay.
Again, depending on the CAP group.
Yeah. Thank you.
Okay. Thank you. We have to move on now.
Yeah, so far so good. There's a big timer in the front. It's flashing in red. There are people waving signs. 1 minute, session ends. But so far so good. Puts a bit of pressure on the next speaker, perhaps. Dr. Castella Langley, postdoc researcher at the University of Cambridge and examining cognitive impairment in young pre-manifest HD patients. The stage is yours.
Great, thank you. I'd also like to start off by thanking the organisers for inviting me to present our talk. And I'm going to be presenting some of our recent results of the cognition in the HD young adult study. And of course, this is a collaboration with Professor Sarah Tabrizi's group at UCL. And I have no idea how to use the clicker. That way. So over the last 2 to 3 decades, there's been a real sort of surge in the interest on the cognitive manifestations within Huntington's disease. And typically, obviously, the motor symptoms were what we focused on, but actually there have been multiple studies now that have shown that there are cognitive impairments even years before clinical motor onset. And of course, cognition is really important not only from a clinical perspective, but also to patients and their families, because it's very strongly associated with functional outcomes. This can include functional capacity, occupational performance, and also overall quality of life. So there's been a real shift both in the research and the medical community to sort of start looking into not only the onset of cognition, but also the progression of cognitive profiles. And this is ultimately to lead to potentially novel treatments. So one of the aims of the HD-YAS study was to actually look at cognitive profiles in gene-expanded individuals very far from disease onset. So as Nikki's already established the group, I'm just going to mention very briefly that we had in total 73 HD gene-expanded individuals and 81 controls that were analysed in the cross-sectional analysis, and 57 gene-expanded individuals and 46 controls in the longitudinal analyses. And importantly, there were no demographic differences between these two groups. So we employed a really extensive battery of cognitive tasks. This included the HD core battery, which of course is the symbol digit modality test, the semantic verbal fluency task, as well as the Stroop task. But we also included an additional number of tasks from the Cambridge Neuropsychological Test Automated Battery. And this included tests of cognitive flexibility, memory and learning, response inhibition, sustained attention, as well as planning and executive function. We also included some tasks that were hot or social and emotional cognition from the emoticon battery, and these included a emotion detection task, a moral judgment task, and also a task of apathy. And it's just worth noting that the tasks that we used for apathy at baseline and follow-up visits were different due to participant feedback about the task. So our cross-sectional results showed that the HD gene expanded group performed worse in the CANTAB stop signal task, the CANTAB rapid visual processing task. So these are tasks of response inhibition and sustained attention, and they also had slightly lower performance in the verbal fluency task, but there were no associations cross-sectionally with age and CAG. And importantly, for the longitudinal group differences, there were none. So there doesn't seem to be any difference in the rate of decline. Although there were some associations with age and CAG, specifically the paired associate learning, the stop symbol digit modality task, as well as the rapid visual processing task, all scores decreased as age and CAG increased. So to conclude, there were no evidence of longitudinal differences between gene-expanded young adults and controls. There is some subtle evidence of an impairment in sustained attention, and I should point out that this was specific to the target detection and not the mean latency. So it doesn't seem to be a motor or a processing speed response. It does seem specific to sustained attention. And this is also associated with predicted years to onset. So this might be subtle, but there does seem to be some early impairment. And interestingly, neuroimaging studies have shown that RVP and sustained attention performance involves the inferior frontal gyrus. And actually, this region is also involved in stop signal performance and response inhibition, which was one of our other tasks that we showed some cross-sectional differences. So it might be that there are some early cognitive impairments in regions that are observed by the inferior frontal gyrus. And finally, I'd just like to mention that, interestingly, both the stop signal and the RVP are impaired in the neurodevelopmental disorder, attention deficit hyperactivity disorder. So this might seem to suggest that there might be some neurodevelopmental mechanism in Huntington's as well. And perhaps some of the further longitudinal follow-up that we have planned might help us to elucidate whether this is neurodevelopmental or neurodegenerative. So I'd like to, of course, finish by thanking all of my collaborators, many of which are attending the conference the next couple of days. I'd also like to say a special thanks to all the YAS participants that took part and our funders, the Wellcome Trust. Thank you very much.
So we have time for one or two questions. Plenty of time.
Thank you, and thanks for a lovely talk. I just wanted to ask, are all the controls family controls, or are they non-HD family controls? Just I wonder whether there might be a difference, at the cross-sectional stage if you were growing up in a family with Huntington's disease.
So there is a combination. Some are gene negative, some are partners of gene positive, and then there are some community controls as well. There has been research that I'm aware of that has actually looked at whether there is some actual bias, even in just controls, whether they come from a HD family or not. But I don't think they're very conclusive.
Thank you.
If no one else, thanks a lot for the nice presentation.
Then it is my pleasure to introduce our next speaker, Kali Reubert. She is a PhD candidate of the clinical neuropsychology at Monash University as well. And we stay in the field of cognition. And her talk is about identifying meaningful cognitive symptoms in Huntington disease. Do cognitive measures capture what matters to patients and care partners. Welcome. We are looking forward to your talk.
Thank you very much for having me. I'm really honoured to be here. Like was already said, I'm going to be presenting some of the results from one of my PhD studies, which has been focused on looking at whether cognitive measures are capturing things that actually matter to people with HD and care partners. So before I get into it, I'll provide a little bit of background, starting with providing a definition for clinically meaningful change. So clinically meaningful change is a construct commonly used by clinical trial regulatory bodies like the US Food and Drug Administration or the European Medicines Agency to describe important change in how a person feels, how they function in their day-to-day life, and how they survive. Now, we know that cognitive symptoms in HD are extremely impactful to day-to-day life, not only for the people who are experiencing those symptoms, but also for their loved ones who we know experience increased burden due to these changes. And as such, it's really an important area to target in clinical trials. And while we have cognitive measures that are extremely sensitive and have been developed for use specifically within clinical trials for HD, no research has actually explored whether these measures are capturing symptoms that are clinically meaningful from the perspective of the people that matter. Now, this is really important because regulatory bodies like the FDA have really emphasised the importance of including the patient perspective at all stages of clinical trial design, including in the selection of clinical outcome assessments, in order to ensure that clinically meaningful outcomes, such as function, are being captured. So with this background in mind, we aim to map meaningful cognitive symptoms and their impacts to the tests of the Huntington's Disease Cognitive Assessment Battery, or the HD-CAB. So our approach to this was heavily inspired by some of the work done by our co-authors. Essentially, we wanted to use a symptom mapping methodology, which is a way that you can sort of delineate important and meaningful symptoms from the patient perspective and sort of collaboratively create a map of what matters to them. So for this approach, we used a cross-sectional design which had 3 key stages. In the first stage, participants completed any tests or questionnaires, and then we moved on to the symptom mapping process, which I'm going to describe with a little bit of a demonstration. So, as you'll see on the screen, hopefully, basically this was the symptom mapping process. We used a semi-structured interview methodology to discuss with patients the changes that they were noticing, as well as why it was important to them. We had patients rate how important each symptom was, as well as how bothersome or impactful they found each symptom to their day-to-day life. And we also included in the map how these symptoms were impacting their day-to-day activities. After this, we moved on to the final stage, which is where we discussed with our HD participants their experience completing the tests of the HD-CAB, as well as where on the test they thought the test best fit, so which symptoms they thought the tests best captured. This was then included in the map, as shown in this picture here. So I won't have an opportunity today to discuss the results in great detail or discuss the results from our care partners, but if you're interested, please come to my poster and I'm happy to discuss it further. Basically, we used thematic analysis on the interviews to identify some key themes, and for our HD participants, we identified 4 key themes in how they felt cognitive symptoms were impacting their day-to-day life, as well as their view on cognitive measures. To describe one theme in greater detail, participants talked a lot about how cognitive symptoms were impacting their day-to-day activities, as shown by these 5 sub-themes. And one area that they described as really impacted was their ability to work. So participants talked a lot about how different symptoms, such as changes in planning abilities, memory dysfunction, and slowed thinking speed, was impacting their ability to do their jobs. This is demonstrated in this quote here from one of our lovely participants who talked a lot about how slowed thinking speed was actually an early symptom that he recognised because he wasn't able to keep up in his busy work environment. So ultimately our goal was then to map these meaningful symptoms and impacts to the tests of the HD-CAB. I'll just provide a very brief overview of a couple results just to give you a bit of a flavour of what we found. So the Hopkins Verbal Learning Test is a verbal memory test commonly used in clinical trials. This was primarily mapped to memory by 76% of our participants, with over 94 participants agreeing that this test was capturing meaningful or bothersome symptoms. In terms of the key impact that was thought to be relevant to this domain and to this test, participants talked a lot about how their social interactions had been impacted by these changes. The emotion recognition test, also commonly used in clinical trials, was primarily mapped to emotion recognition, unsurprisingly, by around 75% of our participants, with over 70% of participants stating that this was capturing important or bothersome symptoms. And I just want to highlight that that was actually the lowest level of agreement for important symptoms, showing that overall our tests really are capturing important and bothersome symptoms for people with HD. The primary area that was sort of mapped back to this was for their relationships, so their ability to interact with their loved ones. The main outcomes that we found, I think unsurprisingly to probably most of the people in the room, cognitive symptoms do appear to be very meaningful and impactful for day-to-day lives for people who are affected by HD and care partners. And additionally, the HD CAB does appear to be capturing symptoms that might be considered clinically meaningful from the perspective of those with HD. Thank you to everyone involved in the study.
Thank you very much for this nice presentation to this really important topic. I mean, we have many discussions about what is clinical meaningfulness when it comes to one point in a scale. Are there any questions from the audience? I do not see a hand, so I ask a question, but please feel free to ask. So from your results, the most meaningfulness measure, was this memory, and was this then related to what you asked, and that is work, probably the most relevant aspect in life for patients?
Yeah, so work was a key impact that was reported from memory dysfunction, but also social interactions was something that they talked about as well, so their ability to communicate with their loved ones.
So would it make sense to focus on this specific part?
Sorry, say again.
Would it make sense to focus on this specific part as this was most relevant?
Yeah, I mean, I think for each person it's quite different, but there's definitely some utility in focusing in on what is considered most meaningful overall, but definitely taking in that individual perspective as well.
Okay, great. Thank you very much. I don't see any hands, so we move on. We switch topics. We come to physiotherapy, but this is as well very important for our patients as a non-pharmacological treatment. And it's my pleasure to introduce Dr. Una Jones. And she's from Cardiff, from the University Hospital of Wales, and will give us insights about the dissemination of the EHDN physiotherapy recommendations. We are looking forward to your talk. Thank you.
Thank you. Thank you so much to the EHDN for inviting me to talk here, and I am talking on behalf of the Physiotherapy Working Group. So at the Physiotherapy Working Group, we have created knowledge in terms of carrying out clinical trials, and we're working at putting that knowledge into action, which aligns with the knowledge to action framework. So a lot of our work is based around that. So if we think of the first generation knowledge that was created within the Physiotherapy Working Group, the first trials were carried out by Laurie Quinn and Monica Busa, for example. And then the clinical trials were used to create the second generation knowledge, which were a systematic review authored by Nora Fritz and the clinical guidelines authored by Laurie Quinn. So in 2020, these clinical recommendations were published. They were based on the systematic review and also on expert opinion. So within this, we have 6 recommendations of physiotherapy practice. So we have an evidence base to our practice. But then this year, we carried out a survey to see were these guidelines being used at Enroll-HD clinics or centres of excellence within the US. And it sort of affirmed what we thought might be the case, is that actually they're not being used. So only 27% of people are actually using those. Now that may be dependent on who answered the survey, etc. Within that survey also we found that 50% of people attending clinic were referred to physiotherapy, and in terms of resources provided, many clinics didn't provide any resources about physiotherapy. Some provided local. In some, there were in-clinic physiotherapists, but really there was a lack of information being provided there. And if we think of our goals within the physiotherapy working group of providing an internationally consistent approach to physiotherapy and providing freely accessible information to the community, going back to 2020, we thought, well, we need to actually provide information that will put this first and second generation knowledge into action. So we looked at the 3 recommendations from the guidelines, those with the highest grade of knowledge. So one on physiotherapy, aerobic exercise and body strengthening, with gait training and with balance. And we created fact sheets. And we used the same information to create 2 different types of fact sheet. One was for people with Huntington's disease, so using a language that was more appropriate there and using figures to sort of indicate how often you should carry out aerobic and resistance training. And also we provided fact sheets for healthcare professionals, talking much more in our clinical language, so using FIT principles, if anybody understands that, 3 exercise, so frequency, intensity, time. And we've provided these sheets in an online version, so you can visit us at our working group page here, and within there we've got all the fact sheets, just in English at the minute, but you'll also find the clinical guidelines and other information that's relevant there. But we've also provided them in paper form because from our work we've understood that healthcare professionals want information online that's easily accessible to them as they move around, but that people with Huntington's disease actually want paper formats as well. So we have provided paper formats out in the foyer. Please visit our table there, and you can visit our poster as well on 007, H007. So what are our next steps? Well, our big next step is actually co-designing resources for people with Huntington's disease living in the community. If people aren't getting the resources from the clinics they attend, how could they actually achieve, get information? So we have a GROW co-design workshop tomorrow in the Amsterdam room. Anybody who is attending here is welcome to join that co-design workshop. We are also doing a follow-up survey to see if actually providing information has changed practice and action in the clinics, and we want to translate our fact sheets. So I just want to thank all the participants and funders of the studies that led to the generation of the knowledge, and the physiotherapy working group for putting this into action.
Thank you very much. May I ask, why do you think it is so difficult to disseminate the recommendation, 27%?
I think it is difficult because within the clinics, there are a couple of reasons. These were the specialist clinics, so they have a really quick time scale of having to get through everything that has to be done, the enroll assessments. They may not have a physiotherapist on board, but it could be that healthcare professionals are not aware of what physiotherapy can actually provide for people, what they can do to help improve the quality of life. So that's why we wanted fact sheets for healthcare professionals, not just physiotherapists, for neurologists, anybody working in the multidisciplinary team, to gain more understanding of what can be achieved.
Okay, so hopefully take home with you this message. We have 1 minute time left for one further question.
You can see.
Yeah.
Kia ora. Thank you for your talk. Do you think that physiotherapists need extra training, or is these things that ordinary physiotherapists can undertake without extra training?
That's a wonderful question, and in fact the answer is yes and no. So we have many specialist physiotherapies working with Huntington's disease that have so much knowledge and understanding, but Huntington's disease is a rare condition. You may have somebody working in community who may only meet somebody with Huntington's disease once or twice in their lifetime, and therefore they may need more education, postgraduate education and possibly undergraduate, and that's part of our next step within the working group, is to think about how we can actually get all physiotherapists to provide very similar quality of care across the world.
Thank you very much. I see there's one more question. Please be fast. So fast question and fast answer, please.
Yeah. A lovely talk. From which age and phase of HD this data was collected?
Sorry, can you repeat that again?
From which age and phase of Huntington this data was collected? People vary. Which age group was that?
Oh, this data was collected from Huntington's disease clinics, so it would have been the people coordinating the clinics that provided that information. So I'm presuming that the age range of people was from early stages through to late stages. I'm not sure, it could have been pre-symptomatic as well.
Thank you so much.
Thank you.
And now something completely different. I myself also a cartoonist. I draw chickens to explain to the HD community, but especially the Dutch society, what is HD, and also to create awareness. And awareness that taboo we're aware of. So I'm very enthusiastic about also the next presentation by Selene Capodarca from Colombia. She's an Enroll-HD global project manager, but also linked to Factor H, and she's an artist. And she will present a presentation on generating awareness and working with local artists to bring HD out into the open.
Thank you, and thanks very much for the opportunity of being here. When I was communicated that the poster was selected, I was so super excited, so thanks very much. I'm actually from Italy. But it's so yes, so the, yes. So I'm going to be introducing Factor H first because it's the not-for-profit organization that funded and sponsored the Art4HD program. So Factor H was created in 2012 with the mission of improving the quality of life of community affected by HD in poor areas of Latin America. They work on many different activities. These are the 4 pillars, so health and disease management. They support community development. They have a special program on youth and kids, and then they collect epidemiological data that allows them to implement action to improve the quality of life. There is a poster on Factor H. It's the H205, so I will invite you to have a look at the poster, and there is also a table just outside here on Factor H. So the Art4HD program is basically an umbrella project that envisages different types of art. Street art, photography, hopefully dance in the future, and any sorts of art as a really strong tool to raise awareness, give visibility, and ultimately promote social changes in those vulnerable communities in Latin America. So for that purpose, the idea is to work with local artists to bring international visibility on those communities. So at the moment, we have 2 major projects under the program. One is the Street Art for HD, and then the other one is the photography project by Vladimir that I'm going to be talking later on. So the Street Art for HD, we painted the first murals on the northern coast of Colombia. where you know the incidence of HD is very high. So there were 4 murals that were painted by 2 very renowned artists from Colombia. If you happen to be in Bogota, if you have been in Bogota, most of the murals, a lot of the murals that are around the city, they are from Digelu and Lesivo. And the murals were focused on 3 main themes: the person affected by HD, as well as the caregiver, and ultimately the children. You can see the artist here at work. So why street art? So there is a lot of stigma in many places, but especially in those areas about HD. So HD is obviously all around, but nobody talks about it. So street art, so it's like this elephant in the room that nobody sees. So street art is really like there on your face, it's on the wall, and you cannot ignore it. So it really makes visible the invisibles. So these are some of the murals that the artist had produced. So this is, it's about family. So it's a father and a son from Medellin. And you can see the villages where they were painted. This is Daisy. You can see her in the middle, and that's a picture from her and her dad that passed away. So that's little Daisy in the picture, in the mural, and that's her dad who passed away. This is Delia. So you can see the writing. It says dedication. Well, dedication. So Delia was really I think we couldn't have picked a better example of caregiver. So she cared for all of her life about her husband, she had 8 children, and she cared about 6 of them that were affected by the disease. This is the murals of the children in San Angel, and the boy in the middle, Oliver, very sadly passed away from an infection that could have been cured, but it hasn't been cured has been poorly cured because of lack of access to medical care. And that's her mom, second on the left. So it was very touching. So that's Vladimir. The other project is the photographic program in collaboration with Vladimir Marcano. That is a wonderful, wonderful photographer. So he has, you can find his book, El Mal, that depicts the families in Barranquilla in Venezuela, and now works with the kids. The kids program, the Progetto Abrazos. And there is if you happen to be in Taufkirchen or in Munich, or if you want to be in Taufkirchen or in Munich, there are 2 exhibitions coming up from Vladimir. This is one of the pictures. These are some information about Factor H or about street art. We have a page on Facebook and an Instagram page, and that's my contact. If anybody has any idea, or if you want additional information about the art program, you can just contact me on the email address. And that, finally, last but not least, how can you support us? So out there on the table, there are some stickers so you can help us really spreading the word by you can take a sticker from wherever you are. These are some examples that were taken in Rome, in Medellin, and Bucharest. But the idea is to really spread the word all around the world. So if wherever you happen to live or to be, if you can get a sticker, put it on. I know you're not supposed to, but you can put it on poles or trees or whatever you want, and then you can tag it with the Street Art for HD. You can see the QR code as well to support Factor H. So if you want to scan it, or there is, you can just go on the table or on the website. That's it. Thank you.
Thanks so much for the inspiring presentation and images. Questions, ideas? Yeah.
Thank you, Selen. That was really a great presentation, and I would like just to admit that we will host this exhibition in Taufkirchen in Germany and in Munich, and we are very open to send this presentation and to continue the journey through the world. So if you are welcome to contact Selen, and we are happy to move the pictures and the photographs to different places in Europe. It would be really nice.
Thank you, Elzbieta.
If no more questions, thank you so much. A number of times the posters were mentioned. Amongst you, hidden, are people that will judge the posters today and tomorrow during lunch. So if you do have a poster, grab a lunch, but quickly do join your poster, present your poster with energy, because the people that will judge your poster will be here and tomorrow.
Yeah, thank you. Thank you for the great session. Sorry for ruining the transition. Go to the posters and the lunch now. Thank you.